Now Dart exposes a data type called either. You see, so it has a left and a right side. So it can have two types. So we basically have two types in one. Right, so we have a left side. In this case, the left side can return an exception. We can have a right side which can return void. So when we save this, we can simply say the result of this function dot left or the result of this function dot right. So if we check and the left is null, then we know, right, that the exception wasn't thrown. If we check and the right was null, then we know that there was an exception. So meaning that this side didn't complete, it was this side that completed. So either one of them must be returned, right? So when it returns the left side, we know there's an exception. When it returns the right side, we know there was success. All right, so let's go ahead and use that. So it will be future either. Over here we can have an exception, but then remember in clean architecture we have to separate our ideas. We have to separate the interfaces. So in this case, we will not directly be dealing with exceptions in the domain layer. All right, in the domain layer, we will be dealing with our own custom type called a failure. All right, so we will create a failure. So a failure will contain the message and the status code from the server. All right, but then an exception will live in the data layer because the exceptions are things that we get from the server from Dart. Remember, the data layer is there to interact directly with the external services. So these external services will throw exceptions at us, and we expect the data layer to catch those exceptions, convert them into a suitable failure for us, and then return them here. So for that reason, I'm going to go into our lib, create a new file. We're going to call, right? And let's go into errors. Let's create an errors folder, and in there we'll create failure.dart. Right, so we will also start by creating an interface first. So this interface will be called failure. All right, and failure will extend equatable. All right, because we want to know if a failure is the same as another failure. With exceptions, we can't really know if two exceptions are the same. Right, so when we're testing, we can't really know if two exceptions are the same, so there's no way to know. This is actually why we need to create a separate class for our exceptions so that we know how they work, right? So let's go ahead and do this. So constant failure. It will have required this dot message and required this dot status code. Final string message, final integer status code. All right, so and then we can override I think it's a list of objects. Get props is equal to, we want a failure to be equal to another failure when the message and the status code are the same. So and the status code are the same. Now this is an interface, all right? So in order to actually create our own failure, what types of failure are we expecting? We can expect a server failure, a failure from the server, right? So remember that data sources, we can have different types of data sources. We can have data sources from servers, we can have data sources from APIs, we can have data sources from the local storage or from a local cache, from the user's device's cache. Maybe we're trying to get something from the user's device, right? And if that doesn't work, then we can get the information from, we can get an error from that cache. So we can call maybe that a cache exception, sorry, a cache failure, right? And we can know, so whenever that happens, we know the problem came directly from a cache. In this case, we're using an API. I'm going to call that an API failure so that we know that it came from the API, and that will extend the failure, right? And in here we can have a constant API failure, and it will required super dot message So it simply takes the same thing that the superclass takes, super.status code. Remember, if you don't understand this, go take our simpler Dart course, simpler Flutter course. Courses, we have a lot of courses on this channel. You can go ahead and take any of them that are beginner friendly. This is for, I think, intermediate developers. So, but then I'm just going to explain, just in case, right? So, what's happening here is we're basically saying collect a message from this constructor when we call that, right? And then pass it to the superclass. So we basically have a failure at the end of the day. So if we call that failure dot message, this message, it will be passed from here. All right, so we have an API failure. All right, so over here we're expecting either a failure, type failure. So these things all are principles of solid. Instead of directly stating over here that we have an API failure, we state that we have a failure rather. So these are I think this falls under dependency inversion, I think. Don't know. Don't really know. All that stuff. So over here we either return a failure or void. Alright, so but then just remember, do not state the actual failure that you're expecting, because in this way, when we do this way, if the type of failure changes, we don't have to go into all of our repositories to change them. Alright, so this is why we call it loose coupling. So if eventually the type of failure that create user expects changes, maybe if we rather want to create user to get a server failure and we have a server failure inside of our failure, maybe we create a server failure and stuff, and then we want this to rather use a server failure. Simply in our data source, when we're returning this, right, we will return a server failure instead, and this can actually still use this. Alright, it can actually still work. This class will work. We don't have to touch this class or change any of its existing functionalities. We only extend its functionalities and add whatever feature we want to add. I spoke about this in the previous session. Alright, so let's go ahead and do the same thing for you. So over here we have either a failure or a list of user. All right, so now in all of our repositories, so if we had a big application, each repository will use this format, and we will use this same format in our use cases inside of our data, inside of our repository implementations, and a lot more places. In order to avoid all of that repetition, we can simply extract this type because it's long. It's really long, so in order to get that to work, we will extract this into a separate new Dart file. In the core folder, we create utilities. Inside of utilities, we can have type definitions. So type devs are a way to create one short generic name for a type, right? So we can create a type dev by saying typedef, and we write the name of the type. So in this case, we can use result future, right? And we can say that result future, whenever someone says result future, we want to know that they're talking about this, a future either failure, import. What is the matter? Import Dart. Right, so we want to have a future either failure. But then remember that this part is going to be different for each person. So this part is basically going to be the same. Alright, so this is why also another good strength of clean architecture. The clean architecture makes sure that there's harmony in your code base, right? So with that harmony, we can do stuff like this. Create one type definition, knowing that every single person who wants to use a future either will be sure to have a failure on the left side, and then the actual successful return type on the right side. So in order to do that, to make that generic, we can add a generic type over here and call that T, and then we can pass that T over here. So whenever we call result future, just like either, we can open and close these angle brackets and put in the types. In this case, we only want one type, and that's going to be the type that we pass here. if you want to also make this place generic, you can also maybe add another type and just add it here instead. But we're not going to do that, right? Let's go ahead and do this. All right, close that up, and let's see. Right, so over here we can just remove all of this, and we can say result future. It returns a failure or a list of users, right? And over here we can do the same thing. Result future. We can even make one for void, right? So for every function that returns void, let's go ahead into our type definitions. We can make one called typedef result void, and then we can just make it to be the result future void. All right, so its other type will be void. So it's basically the same as this, but with void in here. All right, so we can go in to our repository and rather use result void.